Okay, so if you weren't here, which I know we had a lot of people weren't here, but if you just want to go over incomplete dominance again, here it is. So what we've really done so far with genetics is we have taken the difference between dominant and recessive. And if we look at what we've done so far, if we were going to take a homozygous dominant red flower, which is capital R, and cross it with a homozygous recessive flower, that would be white. We have lowercase r. What we would get is the probability of the genotype of heterozygous for to be 100%. So 100% of the time, if we mix those two, we're going to get the probability of 100% of the time that we will end up with a heterozygous offspring. This is a little different now. Scientists have found that some traits in which one allele isn't actually dominant over the other, but that each allele has its own influence, and this is called incomplete dominance. So we look at the white flower, and we cross it with the red flower. And instead of the red dominating, they both have their own influence. And so we end up with pink. Now, if we look at some examples, this first example is talking about if we were to take a pink and a white carnation and cross them, what we would get. Well, we take the R from here and we take the W from there. And so in this top box, we get R, W, and here in this box, R and W, and up in these boxes, W, W. Okay, so the basic Punnett square principles are still there. It's just a completely different thing now. Our two colors that we see now are going to be pink and white. And we see both of those we see both of those 50% of the time. And the reason we know that is because each one of them is 2 out of the 4 boxes. Now down here we have a curly-haired person and a straight-haired person, and when we combine those two, they combine to be wavy. And so the Punnett square wants you to combine 2 wavy-haired people. So we're going to have SS, and that is going to stand for straight hair, and we are going to have CC, which is going to stand for curly hair. And then we're actually going to make another one just to keep things clear, and that is going to be SC, which is going to equal wavy. Okay, so what happens when we combine 2 wavy-haired individuals? Well, we just said that this will be, and if it's wavy, it's SC. Same thing over here, we get S and C. And so in this box, we get SS. Over here, we get SC. Down here, we get SC. And over here, we get CC. So the different genotypes that we now have an option of looking at are these right here. These are our different genotypes that we can pick from. So we have the probability of SS or SC or CC. And the probability of having SS is 25% because it's 1 out of 4. The probability of having SC is 50% because we have 2 out of the 4. And the probability of CC is 25%. Again, 1 out of the 4. The different phenotypes that we have here are straight, curly, and wavy. And the straight probability, that only occurs when we have SS, that is 25%. our curly probability, that only occurs when we have SC. That's 2 out of the 4 there, so that's 50%. Or, sorry, that's 1 out of the 4 there, so that's only 25%. And then our wavy probability is 2 out of the 4, the SCs, so that would be 50%. So what is the probability of all of these different ones? Well, we have a 25% chance of straight, 25% chance of curly, and a 50% chance of wavy. Okay. More practice of incomplete dominance will come with SpongeBob. So refer back to this if you need any help on SpongeBob, but I think once you understand the regular Punnett square, incomplete dominance comes very easy. Let me know if you guys have any more questions.